everyone, my name is Miniseti. I hope you all are staying healthy. Today we are going to talk about derivatives and slopes, and we will also see one numerical question to find out difference quotient. First of all, we will solve one question to find out difference quotient. With the help of this question, we will try to understand what are derivatives and slopes. So first of all, we will solve one question. Find out difference quotient as a function of x and delta x and y equal to 4x square plus 9. This is given. And this is our formula. With the help of this formula, we will solve this question. This is formula of difference quotient. We have already derived this formula. Check link in description. So now with the help of this formula, we will solve this question. In this formula, this one and this one are basically our x. That's why first of all in this equation, in place of x, we will put x naught plus delta x. In place of x, we put x naught plus delta x. Now we will do a plus b whole square. It will become equal to x naught square plus delta x square plus 2x naught into delta x plus 9. Now we multiply 4 inside, it will become equal to 4x naught square plus 4 delta x square plus 8x naught plus delta x plus 9. This is very easy. Now in same equation, in place of x, we will put x naught. In same equation, in place of x, we will put x naught. Now it will become equal to 4x naught square plus 9. We will go according to this formula. We have calculated this value. This value belongs to this. We have already calculated this value. This value belongs to this. According to this formula, we will minus this value from this value. Okay. When we minus, it will become like this. 4x naught square plus 4 delta x square plus 8 x naught into delta x plus 9 minus 4x naught square minus 9. So this one will cancel out. This one and this one also cancel out. Now our equation will become like this. But we will work according to this formula. According to this formula, we will divide this with delta x. Both sides with divide delta x. This one cancel out. This one also cancel out. This is our final answer. This will be called our difference quotient, which we calculated by using this formula. Now we will see what are derivation. We have already discussed y is dependent variable, x is independent variable, y depend on x. That's why y will change when x will change. If we want to know rate of change in y with very small change in x, then we take help from derivation. If we want to know rate of change in y with very small change in x, then we will take help from derivation. If I am saying small change in x, that means we are going to put a limit. That's why delta x will approach to 0. Here dy over dx represent derivation of function y with respect to x. Here we will set one limit, that means delta x will approach to 0. So this was our answer to difference quotient. Here in place of delta x, we will put 0 because delta x approach to 0. When we put 0 in place of delta x, it will become equal to 8x naught. This is our answer through derivation, and this x naught will be known as the instantaneous rate of change. Suppose if we do simple derivation of our original equation, this was our original equation. If we simple do derivation, this power will come down and reduce by 1, then our answer will 8x. Same answer we have, 8x naught. Only difference is that here first of all we calculate a difference quotient, then we do derivation, but here we directly do derivation. Now we will see derivatives and slope. Derivative tell us rate of change in one variable with respect to change in other variable. Similar, from the slope of curve we can know rate of change. That's why derivatives and slope of curve both are connected. For example, cost is dependent variable, output is independent variable. Cost depend on output. On x-axis we have output, y-axis we have cost, and this is our cost curve. Initial equilibrium point is A, initial output Q naught, initial cost C naught. Suppose output increase from Q naught to Q2, that's why cost also increase from C naught to C2. This will be called change in output, this will be called change in cost. So change in cost equal to C2 minus C naught, change in output equal to Q2 minus Q naught. Change in cost divided by change in output will called rate of change. Same rate of change in geometric we can represent with the help of slope of line. For example, slope of this AB line represent BE over AB. BE over AB. That means this much change in dependent variable lead to this much change in independent variable, or you can say that this much change in output lead to this much change in cost. Suppose output increase from Q0 to Q1. Now our equilibrium point is D and slope of AD line is DF over AF. Slope of AD line is DF over AF. Similar, slope of this KG line GH over KH. Slope of KG line GH over KH. Now think about marginal cost. This is formula to calculate marginal cost. We have already discussed about change in cost over change in output means marginal cost merely tell us how much cost change due to change in output. Slope of curve tell us how much cost change due to change in output. Derivation tell us how much cost change due to change in output. That means marginal cost is directly associated with the derivation. If total cost function is given, then you can calculate a marginal cost by doing derivation with respect to output. If you want to know rate of change in cost with very small change in output, then we will do derivation of a cost function with respect to output. That means we will set a limit. That's why change in output will approach to 0. Whatever answer or whatever value will come, it will be known as instantaneous rate of change, or you can say that it will be called marginal cost. A change in output approach to 0, that means change in output is very small, so that it can provide precise cost of additional unit. So by this way, derivation, marginal cost and slope of curve are connected. So this is all about today's videos. I think you got it. Thank you so much for watching this video. Bye. Take care.